Imagine you build a missile whose entire purpose is to hunt radar. It follows the radar signal like a thread, riding the beam all the way back to its source. You fire it, it locks on, and then the enemy does something so simple, so obvious that it almost feels like cheating. He just turns the radar off, and your million-dollar missile, with nothing left to follow, flies into the ground and explodes in an empty field. Nobody hurt. Radar back on 2 minutes later. Enemy drinking tea. That is not a hypothetical. That is exactly what happened over North Vietnam. And it happened over and over again until America was forced to go back to the drawing board and completely rethink how you kill a radar that does not want to be found. This is the story of the most important cat and mouse game in the history of electronic warfare. A story about a weapon designed to blind an air defense system, and the Soviet engineers and radar operators who figured out how to beat it using nothing more than a light switch and a radio. To understand why America needed an anti-radar missile in the first place, you have to understand what it was like to fly combat missions over North Vietnam in 1965. The Soviets had supplied the North Vietnamese with their SA-2 Dvina surface-to-air missile system, the same system that had shot down Francis Gary Powers' U-2 spy plane over the USSR in 1960. These were not primitive weapons. They were radar-guided, capable of reaching 60,000 feet, and deadly accurate against anything flying at medium or high altitude. On July 24, 1965, an SA-2 shot down an American F-4C Phantom. It was the first of 110 USAF aircraft that would eventually be lost to SAMs in Southeast Asia. The White House ordered a retaliatory strike on the missile site. By the time American aircraft arrived, the SAM batteries were gone. In their place, dummy missiles, used as a trap. Anti-aircraft guns hidden nearby opened fire and shot down 4 of the attacking aircraft. The North Vietnamese had just demonstrated something important. They were not going to fight fair, and they had Soviet advisors teaching them exactly how not to. US aircraft losses were climbing. Pilots were flying into airspace defended by an integrated network of radar-guided missiles, anti-aircraft guns, and MiG fighters, all coordinated through a Soviet-designed system that American air planners had badly underestimated. Something had to change. The Air Force launched an emergency program called Wild Weasel aircraft specifically configured to find and destroy SAM radar sites before the strike package arrived. And they needed a weapon to do it. What they had was the AGM-88 Shrike. The AGM-88 Shrike was conceptually elegant. It was a missile with a passive radar seeker in its nose, meaning it did not emit anything itself. It simply listened for the electromagnetic signal coming from an enemy radar, locked onto that signal, and followed it straight back to the source. Fire it at an SA-2 radar site, and the Shrike rides the beam home, smashes into the radar dish, and the SAM site goes blind. No radar, no targeting, no threat. The idea was sound. The problem was in the execution. The Shrike had a range of roughly 15 miles, shorter than the SA-2's own missile range, which meant the Wild Weasel aircraft had to fly into the SAM's engagement zone to fire. It was slow enough that the SA-2 could outrun it in certain scenarios. The warhead was relatively small, often damaging the radar dish without destroying the electronics van behind it. A dish takes days to replace, but it gets replaced, and its guidance had absolutely no memory whatsoever. The Shrike's guidance had no memory. If the radar shut off, the missile lost its lock immediately and crashed into the ground, harmlessly. The Soviet advisors working with North Vietnamese radar crews figured this out within days of the first Shrike being fired in combat in 1965. The solution they trained the operators on was brutally simple. Watch for the Wild Weasel aircraft. The moment you see it enter your radar, picture turn the radar off. Wait 50 seconds, turn it back on. By then, the Shrike has already hit the ground, and your SA-2 is still operational and ready to fire at the next aircraft that comes through. The Shrike's combat success rate fell to around 25%. 3 out of every 4 missiles America fired at a radar site achieved nothing. What makes this story genuinely fascinating is how methodically the Soviets turned a tactical observation into a full doctrine. It was not just turn the radar off and hope the North Vietnamese air defense system, coached by Soviet advisors, developed a complete set of responses to the Wild Weasel and Shrike threat, and each response was designed to exploit a specific limitation of American tactics and weapons. The first response was the radar switch-off technique already described. But the second was more sophisticated. They began using decoy radar emitters, transmitters that broadcast on the same frequencies as the SA-2's fire can radar, but were positioned away from the actual missile launchers. A Shrike following a decoy signal would destroy nothing useful. The actual radar, sitting silent a mile away, would come back on as soon as the threat had passed. The third response was the flak trap already used in the very first retaliatory strike. A SAM site that looked active on radar turned out to be a dummy. Anti-aircraft artillery was concealed nearby. The Wild Weasel aircraft, descending to attack the radar site, flew directly into a wall of conventional gunfire. 4 aircraft were lost in the very first incident of this kind. The tactic was used repeatedly throughout the war. The fourth and most psychologically interesting response was the ranging technique. Experienced North Vietnamese radar operators learned that they could take a very brief snapshot radar emission, just a fraction of a second, to get a targeting solution on an American aircraft, too brief for the Shrike seeker to fully lock. Fire the SA-2 on that snapshot. The missile would climb into the sky on ballistic guidance, then acquire the target at close range. The Wild Weasel pilot, watching for radar lock to fire his Shrike, never got a sustained lock signal to react to. The SA-2 came up anyway. There is a human dimension to this story that the technical analysis tends to skip over. The Wild Weasel crews, 2-man teams consisting of a pilot and an electronic warfare officer called a bear, had one of the most dangerous jobs in the entire Vietnam Air War. Their mission was to fly directly toward the SAM sites, deliberately invite the radar to lock onto them, and then fire before the SA-2 could fire first. The unofficial Wild Weasel motto was first in, last out. They went ahead of the strike package to clear the way and stayed behind to protect the aircraft leaving. The electronic warfare officers who flew the back seat developed an almost physical feel for the radar environment. They could read the patterns of SA-2 radar emissions, identify when an operator was ranging versus tracking, and call out the threat in the fractions of a second that determined whether the crew lived or died. General Hoblet, one of the most experienced Wild Weasel officers of the Vietnam era, described it this way: "You are never not scared. You learn to work scared." The crews who could not manage that did not last long. You are never not scared. You learn to work scared. By the late 1960s, the limitations of the Shrike were completely understood. The Navy and Air Force launched a new program in 1969-1 with very specific requirements. The new missile had to be faster than anything a radar operator could react to. It had to have a memory so that switching off the radar mid-flight would not save the site. It had to have a wider frequency range so it could detect more types of radar without pre-programming. And it needed a bigger warhead that did not just damage the antenna, but destroyed the electronics behind it. The program was called High-Speed Anti-Radiation Missile, HARM. It took 15 years to get right. The AGM-88 HARM entered service in 1983 and addressed every single weakness of the Shrike directly. It flew at Mach 2+, fast enough that from launch to impact a radar operator had very little time to react. It had a memory mode, meaning that if the radar switched off mid-flight, the HARM continued toward the last known location of the signal and detonated there anyway. It had a broadband seeker that did not need to be pre-programmed for a specific radar frequency. And its 66-kilogram warhead with tungsten fragmentation did not just scratch the antenna, it shredded the entire radar array and the supporting electronics van with it. The Soviets had beaten the Shrike by turning off the radar. The HARM was specifically designed so that turning off the radar no longer saved you. The missile remembered where you were, and it was coming anyway. On the first night of Desert Storm, January 17, 1991, coalition aircraft launched over 2,000 HARM missiles against Iraqi radar networks. FE-4G Wild Weasels, F-16 CJs, F/A-18 Hornets, and RAF Tornadoes all carried HARM in the opening package. The mission was to blind the Iraqi air defense system before the main strike arrived. Iraqi radar operators trained on Soviet doctrine turned the radar off when threatened, found that this no longer worked. The HARM remembered where they were, and it came anyway. The ones who kept the radar on to fight back were destroyed before they could fire. The Soviets beat the Shrike with a light switch. America spent 15 years building the HARM to answer that. Their successors answered the HARM with low-probability radars that emit brief, frequency-hopping signals. America answered that with newer seekers that guide themselves even after the emitter shuts off completely. The game never stops. And then there is Ukraine, where in 2022, American engineers bolted AGM-88 HARMs onto Soviet-designed MiG-29 fighters, one version using a tablet computer as the cockpit interface, to fire against Russian radar systems descended from the same SA-2 that beat the Shrike in 1965. The loop that started over North Vietnam had come full circle in the most unexpected way anyone could have imagined. The Shrike was not a bad weapon. Following a radar signal back to its source is a brilliant idea that still works today. The failure was not in the engineering. The failure was in not asking the one question that matters most in electronic warfare. What does the enemy do when they see this coming? The North Vietnamese, coached by Soviet advisors, had the answer ready before the first Shrike was ever fired. And the answer was a hand on a power switch. Every weapon works until a smart enemy finds the one specific thing that breaks it. And in electronic warfare, that thing is almost always simpler than anyone expected. A missile beaten by a light switch. A 60-year chess match that now has Soviet aircraft firing American missiles at Russian radars. If this is the kind of story you want more of, subscribe to MisfireX and drop a comment. In the electronic warfare chess match, who do you think is currently winning? This is MisfireX. We find the misfires. We tell the truth.